Well, hey folks, how are you? Don Grandt, CTC, cutting tool counselor, here with another exciting episode of In the Loupe TV, sponsored by Harvey Performance Company. Thanks for coming back. Thanks for joining me. Before we get started with this episode, please, you know what to do. Hit the like, hit the subscribe, share it with anybody that you think might gain from the knowledge we bring as a cutting tool company. Subscribers are getting up, and we appreciate your support. It helps me get out to everybody out there and try and bring just a little bit more education when it comes to applying high performance cutting tools. So, what are we going to talk about on this episode? Well, if you watched the last one, we talked about circle segment cutters, or as we call them, HMAF cutters, helical multi-axis finishers. These are the weird shaped radius ones that you use in a 5-axis machine and do all this fast surfacing on your parts. Kind of a new way to look at how we surface. If you haven't watched the episode, please go back and do that. But what we're going to do is I am going to give you some tips and tricks on how to program these a little bit more efficient, maybe take a little bit of that fear out of it. That's what we're doing on this episode. So I am glad you came back, but we can't talk about it here. We're going to talk about it next. So folks, thanks for coming back. I much appreciate it. What are we talking about on this episode? Well, we talked about circle segment cutters, and remember, we're talking these things called HMAF cutters, helical multi-axis finishers. They look like this. Weird shaped radiuses to do surfacing a little bit faster. They're multi-axis, so they go in multi-axis machines. I don't want to dive into it. What I want to do is I want to teach you how to program these a little bit easier and take some of the fear out of it. They have some weird shapes, and there's something to it to actually program them efficiently. Now, how do I know this? Am I a master programmer? I absolutely am not a master programmer. Actually, I'm a novice. So when I needed support on how to program these tools and understand them the way that I needed to so I could apply our tools at the spindle a lot better, who did I call? I called one of our good partners and our good friends, Mastercam. So this actual episode is in collaboration with Mastercam, and not particularly Mastercam. I want to give a shout out to one of the main gentlemen at Mastercam that helped me the most, and that was Jesse Trink. I don't know if you've seen some of Jesse Trink's videos. He does a lot of training for Mastercam. The way he explains things really kind of makes you think and helps you actually program these things better. So a big shout out to Mastercam for supporting this episode, for helping me show how to program these tools, and we're going to dive into it. We can't do it here. We're going to run to the shop. We're going to talk about it next. So folks, here we are at the shop, and I think it's only fitting because of the way I do these videos if we do one thing. Hold on one sec. Seeing as this is supported by Mastercam, I think it makes good sense to have a Mastercam hat on to explain some of these programming on these HMAF cutters. Now, one thing I want everybody to understand when we dive into this is going to be a little bit longer episode, so please fast forward through my ranting on some of the things that you think might not be pertinent to what we're trying to train here, and let's get to the meat and potatoes. But this episode, we really want you to understand some of the principles, right? You're going to walk away with principles of how to program these tools in a way described by my buddies at Mastercam with their software as examples that's really going to help you understand how to do this better. Okay, folks, we're diving in. We're going to talk about HMAF cutters, multi-axis finishers, and the weird shaped radius ones and how to program them. For this episode, we're going to focus on three tools. Okay? We're going to focus on an oval form, which has a bigger radius on the outside of it. It's a little bit skinnier, has a longer radius. We're going to focus on a taper form. I'm going to show you how to use a taper form. Now, taper forms come in all different angles. We're going to explain how those angles work in that program. And we're going to focus on a ball nose. A ball nose? Don, why do you say a ball nose? Well, this is part of the tips and tricks that I learned from Jesse Trink to understand why we're going to use a ball nose. But those are the 3 tools that we're going to focus on in this programming of this part that we're going to give an example is a oval form, is a taper form, and is a ball nose. Let's dive into the programming. Now, folks, before we dive into the programming, I want everybody to understand on these 2 different forms, an oval form and a taper form, what is consistent in these HMAF cutters or circle segment cutters. What is consistent is a contact point from an angle. That is the most important thing that we need to understand when we're programming this. So if we look at an oval form, okay, and this is our oval form, part numbers will be in the program as we go. An oval form has roughly, and I say roughly, and this is plus or minus a degree, 6 degrees per side, or 12 degrees included. So we want to keep that in mind when we're programming this tool, which means we are 6 degrees per side, which means that we want to make sure we're at the optimal point of the radius. Now, a taper form, depending if we're using a 45 degree, whether we're using a 60 degree, whether we're using a 75 degree, those angles are going to come very important to when we do the programming. So keep in mind that those have angles. Now, if we go back to a ball nose, where we're starting, we look at a ball nose, the angle's not as important, is it? A ball nose can twist and spin all the way around that ball. So the angle isn't as important as it is on an oval and a taper form. So when we're programming and when we dive into this part, I want you to think of that. There is an angle. There's a specific angle on every one of these HMAF cutters that we want to keep in mind when we program. Now, enough talk. Let's dive into the part and let's talk about the tips and tricks and actually programming that using Mastercam's latest toolpaths. Okay, folks, for an example, I figured, what do we use for this? And I'm going to use the same example that I was trained on. So if we take a look at this part and we just pull it up on here, and I'm going to spin it around a little bit for everybody can see it. Kind of looks like maybe an engine blade, but you see it's got some surfaces around the OD of it. It's on a base, and it has a bunch of wibbly wobbles that we might use a ball nose to perform to get that surface where we want it. Okay, this is the part we're going to work with when we look into Mastercam. So let's dive into the Mastercam programming on this part and take a look at it. Now I'm going to use Mastercam 2024, but some of these principles I just want everybody to understand will apply to different softwares. So even though we're using Mastercam for this example, pay attention to some of the philosophies that we were taught in using this in order to program it that might apply to other softwares as we get going. So let's first open this up. Now what we're going to use is we're going to use a toolpath. We have to pick a toolpath, right? So I'm going to walk you through my process for actually machining this part. So I have to pick a toolpath. Well, in the latest version of Mastercam 2024, they have this toolpath called Unified Toolpath. Now, a unified toolpath, in my opinion, is the only one that I've ever used for 5-axis machining because it's so easy to incorporate everything into it. So I'm going to use the unified toolpath. So what we do is we pick the unified toolpath. Now that we have the unified toolpath in here, yes, there's a bunch of selections that we can actually pick. But the way that we want to run through this is I want to program this with a ball nose first. That's why I put the ball nose in there. Why do I want to program it with a ball nose? I want clean machine motion. I want clean toolpath. Because if I get clean toolpath with a ball nose, I can start to insert my HMAF cutters with just some small tweaks to get where I need to go. So let's open this up. Let's pick a tool. Let's pick our 1/2-inch ball nose tool that we're going to use for this. 1/2-inch ball nose. We all should know how to program at 5-axis with a 1/2-inch ball nose. Now the next thing I want to do is I want to go into this tool axis control and I want to go into collision control. Want to turn those off. I don't want anything. I want to turn my tool axis control just to surface. I don't want any tilt, and I want to turn all my collision controls off. Remember, what we're trying to achieve with this ball nose is clean tool path. Very clean tool path. I'm really just concerned about this tool path before I go with these HMAFs. So we're going to turn those off and use those later. Now, where all the magic happens in the Mastercam toolpath and the unified toolpath, which is our 5-axis finishing toolpath, is in the cut pattern page. This is where all the magic happens. So if you're not familiar with Mastercam, if you look at your parallels, your morph between, which used to be separate entities, they're all within this toolpath now. You can pick everything you need. You can go to an automatic toolpath, or you can go along a curve, parallel, morph. All those are within here, and I'm going to show you how easy this is to pick. But since we're talking about clean toolpath, let's just pick an automatic. Let's just hit automatic, and we want this to generate us a toolpath. So we'll run through all these settings. We're just going to click automatic, and we're going to generate the toolpath. Let's give it a little bit of time to generate. Okay, now look at that toolpath. Do you think that's a good, clean toolpath with a ball nose? It isn't. You see how we're using the ball nose to determine whether or not we have a real good, clean toolpath. So that toolpath I would not accept with a ball nose before I even go to that. So what we want to do is we want to correct that, and we want to get a good, clean toolpath with a ball nose before we run these HMAF cutters. Okay, so instead of using an automatic because it didn't give us a good toolpath, let's start diving into the selection here where we can start really drilling down. So let's take a parallel, saying we just want to run parallel to a surface. So we'll take this in the unified path. We will click parallel. Now it's going to want to know what we want to run parallel to. So we want to run parallel to the top surface. We'll pick that. Then we're going to pick our entities. And we'll pick all these entities. We're gonna machine all these surfaces around the OD. We're not gonna click the fillets. We just want to machine these surfaces with a ball nose, and let's generate that with a 20 thou step down and see what we come up with. Now looky there. Now that's more of a tool path that I can deal with a ball nose. I'm starting to like this geometry. I'm starting to like this tool path. You see where we're starting with a ball nose because all we're really concerned with is a tool path. Now let's sim this, and you're going to see that this tool is just running parallel to that surface. Don't forget, we took out the tilt and we took out the collision. So we're going to add that stuff in. What we're actually trying to do is get a clean tool path with a ball nose. And I think we've achieved that pretty well. This is your main line of defense when you're programming these. Program it with a ball nose and get yourself a nice, clean, purty tool path that looks something like this. Now let's go to a taper form. This is an HMAF cutter for programming. We like the tool path. Now let's go to a taper form. Here we go. Wake the kids, phone the neighbors. We are getting into this. So now what I'm going to do is I'm just going to go in there and I'm going to swap. I'm just going to swap in my taper form. Now this is a 45-degree taper form. Remember that number, 45 degrees. We know what that is. 45 degree means that's where our radius is. So now what we're going to do is we're going to swap in that tool. All we're going to do now is we're going to go down to the tool axis control. Remember where that tool axis control was? And we changed it. We turned it off. We're going to go in that tool axis control. In Mastercam, we're going to say surface with tilt. Before it was just surface. Now we're going to tilt that thing. Anybody want to guess what angle we're going to tilt that taper form HMAF cutter at? Oh, go ahead. You can tell me. Put it in the comments. I got it. 45 degrees. So we're going to go in here, surface with tilt. We're going to tilt this to 45 degrees. I'm going to extend, go back to the cut pattern page. I'm going to extend my thickness from 20 thou. I'm going to put that at 50 thou. And I'm going to run this HMAF cutter. And let's see what the tool path looks like. Well, looky there. The tool path is almost exactly the same as it was for the ball nose. Now let's sim it and see what that tool is doing and see where we're at with the radius of that tool. right on that radius. Right on the radius, right where we need it. So now, because I was at 45 degrees, remember I told you these taper forms are at different angles, right? 45 degrees, put it 45 degrees to the face. Same program we used for a ball nose, swapped in the taper form, followed the same tool paths, it's at 45 degrees. Now, just want you to think, because we're running through this real quickly. If I wanted, let's say there was things in the way and I wanted to tilt that tool up, I could use a 30-degree taper form, go back to my tool axis control, change it to 30 degrees, and I'm going to be 30 degrees off the face, which means steeper, and I might not collide with something. Okay? Now, if you were taking this tool and this part, and let's say we were flipping it on its side, then maybe I want that still at the same angle. I would use a flatter surface 75 degrees and I would still be able to clear. So the taper form is really simple to program once you get a nice clean tool path. You swap it in, go to the tool axis control, put your angle in there. Yeah, you got some climb mill, you got some conventional mills. You might have to mess with those a little bit to get a right clean tool path, but let's watch this one more time. We're making a really good tool path with a 45-degree taper form. That's pretty cool, isn't it? It's all about getting that clean tool path before you put that taper form in there. Now let's run to an oval form and use the same exercise. Okay, now we're at an oval form. Let's take a look at this. Now, oval form has a bigger radius or a longer radius. It also has a ball nose on the bottom, okay? So remember at the beginning when I said the oval forms are roughly what, 6 degrees per side? 6 degrees or 12 degrees included. So keep that in mind. We have the same tool path that we just did with the taper form. What we're going to do is we're going to swap in the oval form. All we're doing is using the same tool path from the ball nose. Now we're going to swap in an oval form. Anybody want to guess what angle we're going to put that at? It's per side. So 6 degrees per side, we're going to put it at 6 degrees. 6 degrees. Now it might be negative 84 degrees depending on what your software is, okay? But we're going to swap that tool in. We're going to make sure it's tilted at 6 degrees because that's where my radius is. That's how we at Harvey Performance, at Helical, where these tools are actually at, that's how we design them. 6 degrees, main part of the radius. We're going to swap that in. Let's generate it and let's see what the tool path is. There you go again. Followed the same tool path as the ball nose. So now we're following this tool path. That's what's very important to get the ball nose in there. And we're swapping it in. You can see we're right at the right part of the radius to actually do that surface all the way down to the bottom of that tool. So all we're doing, folks, is we're getting a clean tool path with the ball nose. We're swapping in our tools that have a specific radius in a specific position, identified by an angle. It is. The radius is identified by an angle. We're finding out what that angle is. We're using Mastercam software to say, I want to do surfacing and I want to put a tilt. Well, where do you want to tilt it? Tilt it to the angle of the tool. You'll follow the same tool path and you'll get some really good, clean surface motion on your part. Okay, so now we got that. We're going all the way down the surface of that. There might be a question that you have is, hey, wait a minute. If I'm on the fat part of the radius and I go all the way to the bottom, I'm going to have a big gap where there's no radius when I get to the fillet that I'm going to have to clean up. How do we account for that? Well, now I'm just going to brag on Mastercam. Because in Mastercam, what we can do is we can move that angle all the way to the bottom. And the way we do that is, remember where the surface with tilt is? We can go into there. Underneath that, there's advanced options. And we can do a gradual side tilt. So the tool tilts, it stays at 6 degrees at the top, and then it tilts to a different degree at a certain angle till it gets to the bottom, so we can get closer to the ball nose. Now let's just run through that. Let's run like an 8 degrees. What we're gonna say is we wanna start at 6 degrees up here, and by the time we get to the bottom of that, with Mastercam software, we wanna tilt a maximum of 8 degrees to get to the bottom so we get closer to the bottom. Now let's sim this and take a look at it. Okay, so if we start out at the top, and we start running down, you can see where we're at the fat part of the radius. It's right where we want to be. It's maximum radius at maximum diameter. It's what our tool's like. As we start going to the bottom, that tool is automatically tilting to get closer to the tip or the center point. So we are gonna have less to clean up when we get to the fillet, and we can blend with the ball nose a lot easier. Mastercam software is very powerful. It's very easy to use. I love this side tilt. Even if you're using a ball nose, you can actually cut on different points of that ball nose all the way down, all within the unified multi-axis tool path within Mastercam. But we can tilt that till we get to the bottom with an oval. Taper form's not going to tilt as much. And now you're close to the fillet that you can use a ball nose, or you could use the end of the tool to clean up the fillet. Pretty intuitive software. Hey folks, the goal here, the whole goal here with using these bigger radius tools and understanding how to program them is to decrease our scallop height and take a greater step over by maximizing the radius that we have on our tools. Yes, we add a little bit of tool pressure. I got that. You can run a little bit faster in feed with a ball nose because of the RPM, but you are covering so much more surface contact that you are maximizing and reducing your cycle time by using these tools. It's the right way to go. It's what you need to do to get a better surface finish. Okay folks, I try to keep these as short as possible. I know this one ran a little bit. There's a lot here to understand. Listen, if you need some more support on programming these tools, running these tools, we have a whole staff that's trained up on how to use these and how to understand certain softwares to get you there. I want to give a big shout out to Mastercam. Thank you, Mastercam. Thank you for all your support that you give me. Thank you for all the support you give Harvey Performance. We appreciate it, and look forward to working with you more in the future. But before I go, I want everybody to understand there's 3 guarantees in life: death, taxes, and spring passes. Have a great rest of your week, folks.